Hello and welcome to section 6.6, which is on trapezoids and kites. A trapezoid is a quadrilateral with exactly one pair of parallel sides, and it can look a couple different ways. It can look like a brick of gold, like that, or it could be a right trapezoid that would have a right angle in the corner, noticing one set of parallel sides. So the bases of a trapezoid are the parallel sides, so these two sides. Legs are the non-parallel sides, so the other two sides would be the legs. Base angles, the two angles that share a base of a trapezoid. So here and here, two angles that share a base. Isosceles trapezoid with congruent legs. So if the legs are equal, then it would be an isosceles trapezoid. Theorem 6.19. If a quadrilateral is an isosceles trapezoid, then each pair of base angles is congruent. Okay, base angles are congruent, so two angles would be equal. In the diagram, PQRS is an isosceles trapezoid, and measure of angle R equals 106 degrees. What are the measures of angle P, Q, and S? And on that, you can use prior knowledge to help you out. We know that a four-sided figure has 360 degrees in it. How do I know that? By using this formula right here, which we've used several times already. So if you plug in four sides there, 4 minus 2 is 2. 180 times 2 is 360. So I know that there's 360 degrees in there. If this is an isosceles trapezoid, you would also know that these two angles would be equal to each other. So angle S is automatically 106 degrees because angle R is. And then 106 times 2, because you have two of them, would be 212. So you minus this from your total, which is 360. And you have 148 degrees left for the other two. And we also know that this one and this one have to be equal as well, because there's congruent sides. And so if you divide this by 2, the other two would be 74 degrees also. So Q and P would both be 74 degrees. Angle S would be 106 degrees. Theorem 6.20. If a quadrilateral is an isosceles trapezoid, then its diagonals are congruent. That would make sense, because if I went ahead and put the diagonals in here, they'd have to be congruent. These two sides are equal. It's an isosceles trapezoid. These sides are parallel, so there's no other angle at which it can go. Those two sides would be congruent. The mid-segment of a trapezoid is a segment that joins the midpoints of its legs. And I have an example drawn here, right down here. This line right here, QR, you're joining halfway here and halfway here. That is the mid-segment of the trapezoid. So theorem 6.21, trapezoid mid-segment theorem. If a quadrilateral is a trapezoid, first of all, the mid-segment is parallel to the bases, and you can see in this figure here that I have drawn, this line is parallel to its bases. The length of the mid-segment is half the sum of the lengths of the bases. So you add up your two bases, and this is half of that sum. And so then we're going to go ahead and do this example. And so if QR is the mid-segment of trapezoid LMNP, what is X? Well, I know that QR is going to have to equal half of the sum of its bases, which is 4x minus 10 and 8. The base right here and the base here. Okay, so I need to figure out what half of all that is, so I'm going to have to distribute the 1/2. So half of 4x is 2x, half of 10 is 5, half of 8 is 4. So combining this, a minus 5 and a plus 4 would be 2x minus 1. Now I can go ahead and plug in the x plus 2. I could have probably plugged it in the whole way down. QR, I just substituted in what QR is. It's x plus 2, because I know that x plus 2 has to equal this other side. So I'll go ahead and move my x over here and move my 1 to this side. So 3 equals x. There is your answer. And if they actually asked us to figure out what the length was, you would just plug that in to the x plus 2. So 3 plus 2 would be 5 for the mid-segment. And then you could also figure out what that top side is as well. 4 times 3 is 12. 12 minus 10 is 2 for this top piece right here. Theorem 6.22, if a quadrilateral is a kite, then its diagonals are perpendicular. So here I have drawn a kite, and I drew its diagonal here and here, and you can very clearly see that that is perpendicular. So quadrilateral KLMN is a kite. What are measures of angle 1, 2, and 3? So 36 degrees is pointing to this corner right here. If this is 36, guess what? Angle 3 also has to be 36. How do I know that? That diagonal is cutting that angle in half, so it has to be. Angle 1, if it's perpendicular, would have to be 90. And so there I have two sides, so I know 90 and 36. So 90 plus 36 would be 126. So what's left for the other angle would be 54. So angle 2 then equals 54 degrees. So using that information, we will do many more examples the next time I see you. Have a good night.